Alright, so we're going to take the derivative of y, and the key for this one, the question that a lot of people ask is, how do you know to use the quotient rule or the chain rule or the product rule? It kind of depends. The reason you have to use the quotient rule here is because you have two functions. You have a function on the top and a function on the bottom, a function in the numerator and a function in the denominator. So you have to use a quotient rule. Sometimes you can rewrite it so that you don't have functions on the top and bottom. You just have constants, but in this case you can't really do that. So think of it as the derivative is going to equal low d high, low, there's your low, d high, which is just going to be -1, minus high, use parentheses, d low, and now this is where you're going to have to do, to find the derivative of the low, we'll call this g of x. To find the derivative of g of x, we're going to have to do the product rule. So g of x really equals, I'm sorry, not the product rule, the chain rule. G of x is really 4 minus x squared to the 1/2 power.
Mm-hmm.
So you need to use the chain rule because you have a function inside another function. That's why you have to use that. So the derivative will be, take the derivative of the outside, which is this, and then multiply that by the derivative of the inside, which is this. So there's your g prime of x. It's 1/2 4 minus x squared to the -1/2 times -2x. So that was, again, there was low d high minus high d low all over low squared is just going to be 4 minus x squared.
Mm-hmm. Where did the 2x come from?
The derivative of the inside. The -2x, you mean?
Oh,
right
yeah, okay, I got it.
Because it was that's the chain rule.
Okay.
Okay?
And then do you leave it like
So
that?
now we're going to simplify that a little bit, and this sometimes is another hard part of this, is to try to simplify it. So there, I simplified that. Here, this right here, I'm going to pull this and these together. The negative times a negative times a negative is a negative, right? So this is just going to be minus, and I'm also going to put the 2. Let me use a different color so you can see what I'm doing here. That, and this negative in front. When I combine all of those together, the 2's cancel. One of the negatives cancels, or two of the negatives, I should say, so you have a negative. And then, so that's just equals x squared. So it's minus x squared, right? X times x is x squared,
Mm-hmm.
times 4 minus x squared to the -1/2. Do not distribute that -1/2 in. You can't do that. All over 4 minus x squared. Well, you're still not done, because that equals, I'm going to rewrite this right here. I'm going to erase that and rewrite it as 1 over the square root of 4 minus x squared. So I have really a compound fraction right here. So how do you simplify a compound fraction? You multiply it by the least common denominator. So I'm going to multiply everything by the square root of 4 minus x squared, meaning I'm going to multiply that on the top and the bottom, and make sure you FOIL it in. That goes there, that goes there, and that goes there. So when I first multiply this to here, it becomes nicely negative, careful with that negative, 4 minus x squared, because the square roots go away. This right here turns into, the second term on the top turns into a negative, just x squared, because these cancel out right there. And multiplying it here, remember, this is just to the 1/2 power, and that's to the first power. So if you multiply like u times u to the 1/2 power, what do you get?
U 1/2.
U to the 1.5 power, or 3/2 power. So I'm going to get on the bottom 4 minus x squared to the 3/2 power.
Okay.
And that's a much simpler looking problem. You're still not done, because now you can distribute that negative in, distribute this negative in right here, and then add these together, and what happens to your x squareds?
They cancel out.
They cancel out, so you really just have a negative 4 all over 4 minus x squared to the 3/2 power. And you can write that a couple different ways, but that's your simplest form, and that's the answer.
Okay.